All right, so here is number 6. This is also on that same piece of paper we're still on. Okay, this is a tough one. See if you can follow. Suppose we assume the vertical angles conjecture. Okay, so we're allowed to know vertical angles. Write a proof showing that if corresponding angles are congruent, then alternate interior angles are congruent. All right, we're not used to seeing proofs like that. Aren't we used to seeing prove and given? Okay, that right there is actually our given and our proof. So your given, I'm going to rewrite it in terms that we're used to. You are given the if part. What was the if part? If corresponding angles are congruent. So that means you are given, don't write it all out, abbreviate, corresponding angles are congruent. You're given that part. They want you to prove that what? How do you abbreviate this last statement? AIA are congruent. Good job. Okay? All right, so now that's a little more like we're used to, right guys? Okay, we're going to do a T-chart proof like we did before. So make a big T here. And the first step is your given. So you're going to be given corresponding angles are congruent. And step number 1 is given. Corresponding angles are congruent. That's an angle symbol. All right, now, step 2 is going to be blank is congruent to blank because of the definition of corresponding angles. So let's see if you can fill in that blank. So write that out, don't yell it out. It's going to say blank is congruent to blank because of definition of corresponding angles. So look at your paper. Are there any angles that are corresponding in there?
1 and 2.
Yes. Angle 1 is congruent to angle 2 because they're corresponding. Angle 1 is congruent to angle 2 because they are corresponding. So go over to your picture here and mark angle 1 and angle 2 congruent. Remember the number of loops means that they're equal to each other? Okay. All right, we got all that. Now, can you guys look at that picture and tell me anything else? Well, actually look back up here. Suppose we assume that what? Vertical angles are true. So what over here is a vertical angle? 1 and 3. So that's going to be line 3. Line 3 is going to be angle 1 is congruent to angle 3. And I'm not going to put corresponding angles. What are they? Vertical angles, because of vertical angles, V-E-R-T. Vertical angles are congruent. Okay, we're almost there. We're going to wrap this up. 2 more steps. That's all we need. Okay, so you have to listen to this. If I tell you that angle 1 is equal to angle 2, and angle 1 is equal to angle 3,
Then angle 2 is equal to angle 3.
then angle 2 is equal to angle 3. Now, why is that? It's very hard to explain.
Because
Because angle 1 and 2 are congruent, and angle 1 and 3 are congruent. So angle 1 or angle 2 and 3 are congruent.
Okay, everybody want to write down what she said? No. So that, back on proof basics, she's right, but back on proof basics, I gave you a property for this. If you have something equal to something and the same thing is equal to something else, so I look for matches. See how you have a match here with a 1 and a 1? Then these two are equal, and that's called the transitive property. It was one of those things we wrote down a few days ago. Transitive. And that way we don't have to write everything that Sierra just said. So transitive property is the thing that says, if this is equal to this, and the same thing is equal to something else, then those two things have to be equal. All right, now look at your picture. Where are 2 and 3 in your picture? Aren't 2 and 3 right here? So if I put 1 loop here, how many loops should I put on 3? 1, because we just said 2 is equal to 3. We wanted to prove alternate interior angles are congruent. Is that what 2 and 3 are? Yeah, so our final statement is going to be alternate interior angles are congruent, and we put definition of alternate interior angles, AIA. I don't know where Noah is, so you're gonna have to wait. All right, because I'm only supposed to let one out at a time, so just hold on. Let me wrap this up and then I'll talk to you. Okay, if 2 lines are, this is theorem 3.9, if 2 lines are parallel to a third, then all of them are parallel to each other. I think this theorem's kind of goofy, because if you have 2 lines already parallel and you put another one in there, aren't they all parallel? All 3 of them would be parallel. All right, the next one, theorem 3.10, in a plane, if 2 lines are perpendicular, remember that symbol? What kind of angles do perpendicular make? No. What, how much degrees? 90. Remember perpendicular make 90 degrees or right angles? So if 2 lines are perpendicular to a third line, then they are parallel to each other. Okay, the last one, number 7, we're going to draw a picture of it, okay? This is a math Excel question about those 2 theorems. So it says the distinct lines, distinct means that they're all different lines, they don't lie on top of each other. So the distinct lines A, B, C, and D are in the same plane. Tell how A and D relate. All right, our first thing says that what?
They both equal 90.
They're perpendicular, so they form 90-degree angles. That's how you would say it. A is perpendicular to B, right? Okay, go over here and draw that situation. So draw an A and draw a B. And what kind of angles are you going to mark them? 90, right? A is perpendicular to B. Okay, that's the first thing. Then it says next. What's that symbol mean? B is parallel to C. So here's B. How would C be drawn if it's parallel? Line underneath it or above it, but is it horizontal or vertical? Horizontal. You need B and C to be parallel. Now you have C is parallel to D. So how would D go? Another line that's horizontal. It doesn't matter where it goes as long as it's a horizontal line. I'm going to put it above because I'm out of space. So there's D. Okay, so the question says, tell how A and D relate. So look back at A and look at D.
Perpendicular.
Perpendicular. Isn't one vertical and one horizontal? A and D? So your answer is A is perpendicular to D. A is perpendicular to D. All right, good job. Let me show you how that's going to get cut in.